Here we go. Here's the good news, guys. Who liked Algebra 1? Some of you? Okay, if you liked Algebra 1, you're going to love the start of Algebra 2 because it's all review. You have seen this stuff before, okay? It's just that this stuff leads us into bigger stuff. So we're just kind of recapping a lot for the first little while. Yeah?
What happened to 1-1?
We don't do it. It's very basic. I mean, this is very basic too, but not as important to what we need overall. So we start with 1-2. You guys are smart. Okay, we are talking real numbers today. Sorry, my A doesn't really look like an A there. There are real numbers and there are imaginary numbers, okay? Chapter 4, we'll get into the imaginary numbers. For now, we're focusing on the real numbers. And I promise you've seen this before. You did this in Algebra 1, I promise, okay? So none of these should be new to you. But real numbers are broken into 2 different sets. Do you know what they are?
Integers and non-integers?
No. Rational and irrational. Right. So 2 different sets of numbers. Any real number can be graphed on a number line. Okay, you can graph any real number on a number line. So imaginary numbers are a little different. You can't really graph an imaginary number. Hey, it's my turn.
There's a feather in your hand. I don't believe it.
Okay, well, don't worry about it. Feathers don't hurt. So here's how it goes, okay? There's kind of this breakdown of rational and irrational numbers. The rational numbers, how are we going to do this? I'm going to set this up as a big picture, actually. That's what we're going to do. There is a picture, I think, in your book that looks just like this, but this way you kind of have a setup for all the different types of numbers. You'll have to tell me when we're done if you like it this way or the other way better. I'll show you both ways. So if we take this to be real numbers, okay, is this whole box. And eventually I'm going to finish off the box, but I don't want to run out of room right now. So we'll get there. Then in this box, there is rational and irrational. Can anyone tell me an irrational number? Do you remember? Pi. Okay, pi is an irrational number. Remember, pi is 3.14159, blah, 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 blah. It keeps going forever and ever and ever. Irrational numbers are numbers like pi or a number like the square root of 2. When you put the square root of 2 in your calculator, you get this number that never quits and there is no pattern to it. It just keeps going, okay? So this is decimals that don't terminate. What does terminate mean? End. Okay, decimals that don't terminate or decimals that don't end, okay, would fall under the irrational. Or you can say they can't be written as a fraction. Sorry, this is so messy. Okay, so that's the irrational numbers. Everything else is going to fall under rational. So rational numbers are the ones that you can write as a fraction, so like A over B, or terminating decimals, okay? So for instance, a terminating decimal would be like 1 over 8 is actually the number 0.125, okay? It has an end to it. It doesn't just keep going. Or repeating decimals also fall under that. I just decided I like the other way better. Sorry, you have to put up with this now. 1 over 3 or 0.3 repeating, right? So 1/3 is 0.3 repeating. That's a rational number. It's a repeating decimal. Okay? So under that rational umbrella, if this is our big umbrella box here, there are different sets of numbers that we can do. So one of those sets of numbers is the natural numbers. Do you remember what a natural number is? Right. Not 0. How you started. 1, 2. So it's the counting numbers. So 1, 2, 3, and so on and so forth. Okay, so natural numbers are kind of the innermost. A lot of other groups have natural numbers that fall into it. Then your next step out is a whole number. Do you know what a whole number is? That one includes 0. So 0, 1, 2, 3, 4. Okay, so that is going to be our next bubble. Okay, what am I trying to show you here in terms of how the natural relates to the whole or the whole to the natural? Natural numbers are whole numbers, okay? Whole numbers aren't necessarily natural numbers, but natural numbers are whole numbers, and they are rational numbers, okay? The next one is integers. What is an integer? It's whole numbers that are positive and negative. So like -2, -1, 0, 1, 2, and you can keep going in either direction. Okay, so that's the integers. Sorry, I'm scribbling out other things. And then your big picture one is the rational. So this is going to be how they fit into our box. So a natural number is a whole number, it's an integer, and it's rational. An integer is not a whole number. It can be, but it doesn't have to be, right? So you just are kind of seeing the relationship between which ones affect which other ones, okay? Any questions on that? Yeah.
So when you talk about decimal numbers, we just refer to those as rational numbers?
Rational or irrational. So if it's a decimal that ends, like 1.25, that's rational. If it's a decimal that doesn't end, like 1.2378465, and it just keeps going, that's irrational. Okay? So let me just show you in kind of a list form how this goes. Real is always written in math like this. It looks kind of like the P for paragraph, right? It's the double bar down. That's real numbers, okay? Then there is the branch off, okay? Q is rational, whereas I is irrational. And I can make a little key for you down here. So this is real. Q is rational. And you don't need to stress to remember these. It's just kind of a shortcut way to show them. Where am I at? Z would be the next one down. Z is integers. W is the whole numbers. And N is the natural numbers. Okay, so you can kind of see the relationship between them that way. Please don't stress trying to memorize them. At times you might see those abbreviations. I just want you to know which is which. Okay? Questions on that? Okay. 2 quick questions for you then. So Valley has a cross-country team, right? Anybody on cross-country? A couple of you? Yeah. I want to know which set of numbers does not contain the number of people, which we're going to call P right now, who are on the team. Okay, so if we're talking the number of people on a cross-country team, of our left side here, right, of all these, so rational, integer, whole, and natural, which one of those is not going to contain the number of people on a team? Oh gosh, I circled the wrong thing. Of these, my apologies. Which one doesn't contain the number of people on a team? Irrational, right? It's going to be a rational number. It's going to be something like 75 or 32. All of those fall under this column, right? So irrational cannot be, you cannot have 3.14159 blah, 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 people on a team, right? So irrational would not be included. Does that make sense? All right, what if every person on the team had to pay $175.50 for uniform and fees? What set of numbers would that be? That's rational, right? Because there's decimal, but it's a terminating decimal, so this would be rational. Okay, is this all coming back? Do you remember all this? Okay, what would be the best classification for this number? That's an integer. Do you remember what letter was integers? That's a Z, right? So negative 64 would be integers. What would be the best classification for this number? That's rational. You can write it as a fraction. It's rational. What's the letter for rational? That was Q, right? So rational. What about the square root of 6? Irrational, right? Square root of 6 is not a pretty one. It's not a perfect square. Square root of 9 would be better. Square root of 6 we would say is irrational. What would the square root of 9 be? So what group of numbers? A natural number, a whole number, an integer, a rational, right? It could be any of those. You would probably call it natural for its most specific, but it could be natural, it could be whole, it is an integer, and it is rational. Okay. Questions on that?